Here are the solution guides to the homework from last week. And what I wanted to do is go through the solution guides, not only so that you can see the answers, but just give you a little more idea of what's actually happening here. This question about the amusement park ride is that this graph is a measure of how many people per hour are arriving at the ride throughout the day. So when the ride opens at 0, 1,000 people per hour are showing up to get on this ride. Now, as the time goes by here, for the first 2 hours, the rate at which they are showing up for the ride is increasing, and it goes up to 1,200 people per hour. Now, the ride will only accept 800 people per hour. So they move on to the ride at a rate of 800 people per hour. So any time that the rate is above 800, that line is going to be getting longer. When it drops below 800, then the line is going to be getting shorter. Now, it also says that there are 700 people in line when the ride begins its operation. So the ride opens at, we consider this to be 0, okay, at 0 hours, and then the rate is above 800. Here it's exactly equal to 800, and then it drops below 800. So how many people arrive at the ride between 0 and 3 hours? Well, they're basically using the trapezoidal rule here to figure out how many people arrive at the ride between 0 and 3. Now, this might be confusing here, why this has a coefficient of 2 and this doesn't. Well, that's because for the first trapezoid, it's a 2-hour interval. From 2 to 3, it's just a 1-hour interval. And so if you integrate the rate, you will get the change in the number of people. So that means that there are 3,200 people who would have been coming to go onto this ride. Now, as I mentioned earlier, in part B here, the number of people waiting in line is going to be increasing because the ride is taking people at a rate of 800. So between 2 and 3 here, that rate is above 800. So that means that the line is going to be increasing in length. Then for part C, at 3 o'clock, okay, or at the time of 3, when t equals 3, that's when you're going to have the longest line, because it starts off with 700 people, and for the first 3 hours, the rate at which they're showing up is greater than the rate at which the ride, or people that are going onto the ride. And so all we have to do then is, if this is when the line is the longest, we just have to figure out how many people, if at 3 is when the line is the longest, we just have to figure out how many people are on the ride. Okay, so we knew that there were 700 people originally, then 3,200, that was for part A, and then the ride can handle 800 people every hour. So if this is how many we started with, this is how many showed up, and this is how many went on the ride, then we get a total of 1,500 people still waiting in line at t equals 3. And then for part D, we're supposed to write an equation so that we will be able to figure out the earliest time when there will be nobody left in line. So you start off with 700, and then you integrate from 0 to t. T is our variable. And then we're going to use what we have talked about in class. This is called a dummy variable. This variable doesn't matter. It could be a P, it could be a Q, it could be an M, but our variable is from 0 to t, and so our function here, we're going to say r of s ds. And then minus 800t is how many people go on the ride in t hours. And we want to know when that will be equal to 0.